a very important and very interesting topic which is called as wave optics. So which is your unit 7. Right? So I hope you have been already learned about the thing called wave optics, in which we have learned about various aspects of light, and also we learned about the law of reflection, law of refraction, and we learned about various light phenomena with the help of a lens and a mirror. We also studied about the dispersions of light and the scattering of light in that lesson. So in this lesson, wave optics, we are going to learn about the same phenomena, but we are going to say that it's the term of a wave nature. Right? So we know that light travels in a straight line. But in the year of 1678, a Christian scientist called, it is Dutch scientist called Christian Huygens, proved that the light will be deviated or travel with the help of a wave-like nature. So from that money, they arranged a theory called wave theory of light. So we are in this lesson we are going to study details about the various theories of light, and also we are going to prove the law of reflection and refraction through his principle, wave theory principles called Huygens principles, and we are going to study about the various phenomena of light like interference, polarization and diffractions. And we'll study about the various optical instruments which involves in magnifications or in order to see a larger distance objects. Right? So let us start our lessons. So before going to the lesson, we will have an introduction about the theories of light. So what is the theories of light? So from the past till now, there are various theories has been proposed by various scientists. So initially they said that the light is a form of energy and it will travel from one place to another place. So in a form of a wave-like nature. So it travels in a straight line. But later, by some experimental study, they proved that what they proved. So the light will not travel in a straight line, but it will also diffract to form an image. Right? So from that various purposes has been proved and various theory has been written. The first theory is called as corpuscle theory. It was said by Sir Isaac Newton in the year of 1672, and later that first initially has been given by Descartes in 1637. So what they are saying in that theory is, we can say that they are saying there is a tiny, massless and perfectly elastic particle, and they name that particle as corpuscle. So they are considering there is a tiny, massless and a perfectly elastic particle will be there, and they name that particle as what? A corpuscle particle. And also they said that the source of light which is coming from that, right? The source of light will not suffer any losses of mass. So there have been no any appreciable changes in mass will be there. So the mass of the particle will remain the same for a long period of durations. And also they said that due to the high speed of the particle, since it is very tiny and also it is a very high speed, that particle has been unaffected by the force of gravity. And they are saying that the path traveled by the light is a straight line in a uniform refractive index. So they prove that light is a straight line. Light travels in a straight line in the medium in which it has a uniform refractive index. We know that we need any medium to travel. Right? They are saying that it needs a medium, but that medium should have what? A uniform refractive index should be there. And also they said that the energy of that light is nothing but is a kinetic energy of the particle. That is what? Corpuscle particle. So they are saying this by observing the nature and observing the various things, and they have been proposing the first theory of light. It has been said by whom? It has been said by Sir Isaac Newton, and they are saying that they are imaginary, they are saying that there is a particle, but that such particle is not that. Right? But they are imaginary, they are saying that there is some tiny and massless and also a perfectly elastic particle, and they name the particle to be what? A corpuscle particle. And they said that so due to the mass, it is not due to the speed, it is not affected by force of gravity, and the speed of the particle or energy of the particle is due to what? The kinetic energy of the corpuscle. And from that they proved that the light will travel in a straight line in a medium which has a uniform refractive index. And they said that how can we able to see an object? So when we say there is a light light is there, if it is completely dark, we say there is no light. So when a ray of light comes into it, we can easily able to see all the object present in it, right? So we can say that when a light comes and falls into an object and it gets reflected, and that light has been given to our eye, so that we can easily able to see the object. So with the help of light, so by means of reflections by an object of the light, so we can easily able to see the light or objects. So like that they are saying that what they are saying. So corpuscle is a particle which has been said that in vision. So these corpuscle particles falls in our retina. They are saying that what? It falls in our retina. Due to that we are able to see the vision of an object. So initially we can say that when a light falls on an object, we can easily able to see an object. Here they are saying that, so instead of that light, they are saying these corpuscle particle is falling in our retina, and due to that only our vision is visible, and we can easily able to see all the surrounding objects by us. And also they are saying that the different colors which have been arised is due to the varying size of the corpuscle particle. So they are saying that the size of the corpuscle particle will be different for different colors. So due to the difference in their size, we can easily able to view different color objects. So that everything is an imaginary consideration, but until now there is nothing can be proved that such corpuscle particle exists, right? And they also said that this corpuscle particle will be either attracted or repelled by the medium. Right? What is in attraction? It will get it. Repulsion means what? It will make it to move away, right? So these corpuscle particles will be either attracted or repelled by the medium, and they say that from the attraction and repulsion only they can easily able to prove the two laws or two phenomena of light, which is called as reflection and refraction. So what is the reflection? They are saying that reflection of light only will take place when the corpuscle particles are repelled from the medium, and they are saying that due to attraction of the particles, it have given rise to what? Refraction phenomena of light. So they are clearly saying what? So reflection and refractions are due to what phenomena? Attraction or repulsion properties of the corpuscle, and they are saying that so when the repulsion of the particle is taking place, then reflection phenomena has been taken place. When attraction of the particle has been taken place, then that type of phenomena is called as what? Refraction. But this is not properly accepted since it is the initial start and I start to explain about the wave nature or a theory of light, but they are not able to explain properly. There are comes some of the drawbacks in it. What are the drawbacks? It cannot able to explain the reason why the speed of light is lesser in a denser medium than in a rarer medium. You know that there are two types of mediums will be there. One is a denser medium and one is a rarer medium. You know that light travels lesser in denser medium than in a rarer medium, but this theory, corpuscle theory, is not able to explain the main reason for this question. Right? So this is one of the main drawback for not accepting the corpuscle theory, and also this theory cannot able to explain about interference and diffraction and polarization phenomena of light. Only it can explain about what? Reflection and diffraction phenomena. That's why we are not accepting this corpuscle theory. So the next theory we are going to see is what? Wave theory and electromagnetic theory. So the next theory is the wave theory of light. So this wave theory we have already said it has been given by Christian Huygens in 1670. So what does this wave theory mean? I am going to tell you some illustration. So what does that mean? If I drop a stone in a water, still water, right? So what will happen? So when I drop a stone in the still water, there will be concentric circles will be formed in the water, right? We call that as the wave disturbances. So the energy has been equally spread over all the distances and it forms nice concentric circles surrounding the stone, right? We call that as a wavelength. So equal disturbance substance is called as what? So the disturbance of the waves all are equal in length and we call that as a wavelength. Due to that, the same thing has been arised in the second wave. We can call that as what? A small concentric circles will form and which will be overlapped to form a secondary wavelength. We call that as a wavelength. Right? So we will study deeply into it, and also I will share you an animated video for that will clearly explain what is about a wave and how the wave propagation is done. Right? So this is a theory, wave theory. Due to this only the wave optics came into account. He is is the first person who says that. So he says that light is a disturbance from a source that travels a longitudinal mechanical wave. So what do you mean by mechanical wave? Means we can say that if anything need a medium to travel. So here air is there. So due to this air medium only you can hear my voice. If air is not present, if I shout at any high speed, you will not be able to hear. So here air acts as a medium to convey the sound from one place to another place. Similarly, any water can be a medium, right? So through which it can be propagated, means we call that as a medium. So anything which is propagating with the help of a medium means you can call that type of wave as what? Mechanical wave. And it doesn't occur any medium for propagation means we can say that as what? A non-mechanical wave. We call that as what? A non-mechanical wave. So here the wave theory clearly says about that the light is a disturbance from a source which travels as a longitudinal wave, as a mechanical wave, and it says that there is a medium called ether. Right? So in corpuscle theory they said about what? So there is a tiny massless and elastic particle is that which is they name that as a corpuscle. But here they are saying that there is a medium, it's called an ether medium is present there. So due to which everything has been distributed and everything has been shared from one place to another place. So from this theory they can easily able to explain the phenomena like reflection, refraction, interference and as well as diffraction. Everything, all the phenomena of light can be clearly explained with the help of Huygens principle, but they are not able to explain that. So later they proved that the existence of ether medium is wrong. Right? There is no such medium has been prevailing in that. So the presence of ether itself is wrong. Is one of the main drawback of Huygens, though it can easily able to prove all the phenomena of light like what? Reflection, refraction, diffractions and polarization. But they are not able to explain about what? The medium, the ether medium is that the prevalence or existence of ether medium itself is around. Therefore, this theory is not accepted. The next one is what? They are not able to explain about the propagation of light through vacuum. Right? They are not able to explain about the light which has been propagating through what? A vacuum or a free space. And also they are not able to explain the last phenomena called what? Polarization. So we know that these are the 5 major phenomena of light. If anything has been explained clearly about this and also the basic laws of it, then that theory has been accepted throughout the world. What is that? Reflection. Reflection means what? So moving from one medium and getting reflected from a same medium with the same velocity. So when we throw a ball to a wall, it gets reflected back, right? We call that as a reflection. So it gets reflected in the same medium means we call that as a reflection. So what does refraction stands for? So refraction is a bending of light from one medium to another medium. We can say that. So velocity of both the medium will vary, and also we can say that the ray can bend towards or bend away from the normal. So when it bends towards the normal, if it moves from a rarer medium to denser medium, it will be bent towards the normal. When it moves from a denser medium to a rarer medium, it will be bent away from the normal. Right? The next is called as what? Interference. We are going to study all these phenomena in this lesson. What is going to be interference? Overlapping of two waves that is going to give rise to alternate bright and dark fringes means we are going to say that is what? Interference pattern. When two lights or two sources have been merged together, the two sources will be merged and give rise to different patterns of alternate brightness and darkness as a band or fringes will happen. We call that as what? The interference pattern. And what is diffraction? Diffraction is a very interesting one. You studied that. So when a light has been passing through a prism, it has been diffracted into what? Vision color. So splitting of a light or bending of a light into the things are called as what? It's called as diffraction. So the last phenomenon is what? Polarization. Polarization is nothing but the unidirectional passage of a light is called as what? A polarization. And one other very important concept in polarization is it is a one-way phenomena. It proves that the light is a transverse in nature, right? So these all phenomena proves that the light is longitudinal in nature, but this is a one-way phenomena. Polarization is a one-way phenomena that proves light is a transverse in nature. right? So is it clear to you? So we studied about two theories. One is called corpuscle theory. That we studied about corpuscle and that also drawbacks. Here they are saying about what? So that is a medium called ether medium, but the existence of ether itself is a false one. So this theory is not accepted by the persons, right? Now we are going to study about what? Electromagnetic wave theory. So what is that electromagnetic? Both electric and magnetic disturbances are going to be arising. We call that as what? Electromagnetic wave theory. So that disturbance is also going to pass as what? The wave-like nature. So we already studied detailing about what? The electromagnetic waves in your fifth lesson. The same condition, right? So the electromagnetic wave theory is said by whom? It's said by Maxwell in 1864, and here they say that the light is an electromagnetic wave and it is a transverse in nature, so it doesn't require any medium for propagation of light. So that is the only condition, right? Electromagnetic wave is prevailing everywhere, means that is the only reason, because electromagnetic disturbances doesn't require any medium, so that it can be prevail everywhere without the help of a medium. Therefore, that is a very important concept of electromagnetic waves. So light is an electromagnetic wave, and they are saying that it is a transverse in nature and doesn't require any medium for what? For propagation. And also this theory can easily able to explain all the phenomena of light, like what? Refraction, refraction, interference, and diffractions and polarizations. All the five phenomena of light can be easily explained by electromagnetic wave theory. Is it clear to you? And there is some drawbacks is coming. What is the drawback means? It cannot able to explain about the interaction phenomena of light with matter. So like example, the photoelectric effect or quantum effect. So due to that, this theory is also not accepted by that. So these are some of the theories, and the last theory is called as quantum theory. So we are going to see that. The last theory is a quantum theory of light. So we have seen that corpuscle theory of light, wave theory of light, and electromagnetic wave theory of light. All this theory fail to explain about all the five phenomena of light, and also it is not able to explain that the light will travel through vacuum. And it also fails to explain about how the light interacts with the matter, like photoelectric effect and quantum effects. But this quantum theory explains about all the phenomena, and it has been said by Albert Einstein in 1905 with the knowledge of what? So Max Planck, what Max Planck has been derived since 1900 with the help of him. Max Planck's idea, Albert Einstein has proposed the theory called quantum theory of light. So in quantum theory of light, they are saying that so light interacts with the matter as a photon. So what is meant by photon? Stands for photon is nothing but it is a discrete packets of energy. Right? We consider that. So all the things are made up of some packets of energy, and it has a discrete value. So that photon, and it helps me to eject the electron from there. So we call that type of effect as a photoelectric effect. So that is the thing you have been learned in your 12th lecture, right? Photoelectric effects. So quantum theory is the first theory to say that so it has an inductive nature, and the photon is the reason for ejection of all the particles, and photon is nothing but it is a discrete packet of energy, and it takes the equation of E is equal to h nu. So it is the famous equation for energy, right? Energy E equal to what? H nu. H stands for a Planck's constant. It takes a value of 6.625 into 10 power minus 34 joules second. And what is U stands for? U is nothing but it is the frequency of electromagnetic waves. Is it clear to you? Right? So quantum theory is the first theory to clear about all the doubts and clear about all the drawbacks that has been taken place in the previous theory. And now they are saying that so all the things have been given in the form of a photon. So that a photon is nothing but it is what? A discrete packets of energy. So with help of that it is traveling, right? So and it has been given by the equation what? E is equal to h nu. So h is a Planck's constant. It takes a value of 6.625 into 10 power minus 34 joules second, and u is the frequency. Is it clear to you? So that is the theory. So from all this theory, we conclude that what is the conclusion we learn from the theories of light? So we can see that the conclusion about the theories of light is nothing but so light is a transverse wave and it is an electromagnetic wave. So light is a transverse in nature and it is an electromagnetic wave, and we can say that a light has both a wave as well as a particle nature. So that is a conclusion, right? So from all this theory it has been concluded that so light is not only a particle or not only a wave. So a light has a phenomenon of, so light has both the wave nature as well as a particle nature. Hence we call this type of nature as what? Dual nature. Dual stands for what? Two. So in some condition it will behave as a wave and in some condition it will behave as a particle. Right? So that is called as what? Dual nature of a wave. And also we can say that the light has been propagating as a form of a wave, and when it comes to interaction, it interacts as a particle. Right? So light propagates as a wave and interacts with the matter as a particle. So these are the things we have been concluded from what? All the theories of light. Right? And we can say that the wave nature of a light can be demonstrated through some of the things. Means we can say that it can be clearly says that it has a wave. Light is a wave in nature due to what? The interference and diffraction. So if I say interference pattern, we are going to learn that, right? So if I detail, then we are going to study about that. So we can easily say that the light doesn't have a nature of what? Wave. And also in diffraction, it clearly demonstrates to us that light is having what? A wave-like nature. And the transverse nature of a light has been only proved by the phenomenon called as what? Polarization. So only one of the important one mark they will be asked repeatedly in your board examination. They will ask about what? So they will give all the options of all the phenomena and then say that which phenomena proves the light is transverse in nature. So what is the answer for that? Yes, what is the answer for that? It is transverse, which means what? It has been polarization. So transverse nature of a light has been demonstrated only by the phenomena called as what? A polarization. So we can also say that like all electromagnetic waves, that light also travel through vacuum. So it can, what are the drawbacks we have been seen in the previous theory? This quantum theory and the gravitation has been clearly explains about all the drawbacks, and it also able to explain about all the phenomena of light. So we are going to follow that, and we are going to learn about this wave nature of light through these principles, like Huygens principles, right? So now we are going to learn about the wave optics in details. So before going to that, we have to learn about what is how a wave is distributed. So how a wave is propagating. So what does mean by wavefront and what does mean by wavelets, and how the Huygens principle has been helping us to prove about the law of reflection and refraction. So then we later slowly study about the interference pattern, diffraction and polarization, right? So let us start the session, right? So now we are going to study about what is the wave optics stands for. So till now we have studied about what the various theories of light, and from the theories of light we know about the nature of a light and how it is going to behave in different conditions, right? So now we are going to study about the wave optics. So what does wave optics stands for? So wave optics is a topic and that is going to deal with the wave characteristics of a light. So we conclude at the theories of light that light behaves as a wave as well as a particle. So this wave nature or wave optics is the one which is completely going to deal about the wave characteristics of a light, and also going to say that the light propagates as a wave and its direction of propagation only we are going to represent by means of a ray. Right? Though the propagations of the wave has been said as a wave-like nature, but the direction of propagation will be simply represented by a thing called what? A ray. Right? So we can tell, we all understand about this wave optics being the best example for that is a dropping of a stone in a still water. When you drop a stone in a still water, what will happen? We can observe it. Or when a raindrop falls in a still water, a drop will falls in a still water, means what will happen? Nice concentric circles of things will be formed, one another. So that means what? The disturbance has been propagating in the form of a wave from a point of disturbance to the end. So that's why we are saying that the light, we are going to apply the same knowledge in a light condition, and we are going to say that the light is also going to propagate in the form of a wave. Right. So before going into that, we have to know about that. So why it is that it is a point source, right? So this is a point source. When I drop it means it will have a equal, it will form one spherical surface, and if I take any point on because all are equidistant from the surface or distance which has been taken place. Hence, we call this as what? We call this as a wavefront. Right? So we can say that all of things has been overlapped, the same vibrating particles, all the things has been overlapped by a circle. We call that circle as what? Wavefront. And we want to say that means each point on this wavefront will also produce equal distributions of energy to it, and we call this as what? We call this as a wavelets. We call that as what? Wavelets. And each point of this circumstance or this point has been distributing the energy equally towards its surrounding, and that has been overlapped by concentric circles. We call that point as wavelets. And all these wavelets have been overlapped by another thing. We call this as a secondary wavefront. So like that only, a single point disturbance which has been taken place in the surface has been distributed through all the direction of form of a wave, and therefore we are getting a concentric circles at the end. So we call this phenomenon as a wavefront formation. The first thing which has been formed. So all the points which have the same locus of a point, everything have the same state of vibration. We call that as a wavefront. So now we'll define wavefront. What is a wavefront? A wavefront is the locus of the point which all is the same state or a phase of vibrations. So all these points on this circle have the same state of vibration. Why does it have the same state of vibration? Because all these points are equidistant from the center of disturbance. So it has been overlapped as a form, and we call this as a circle, a concentric circle, and here this circle has been represented as what? A wavefront. So here we are representing as what? A wavefront. So we call that as a wavefront, and each point of this wavefront has the energy, and that has been equally distributed over it, and that will form one another concentric circles, and we call that as a wavelets. And all these wavelets have been overlapped by a surface. We call that as a secondary wavefront. So due to that, the disturbance has been continuously spreading in the form of a spherical in nature. So what is a wavefront? What we have been learned? So wavefront is nothing but is a locus of a point which all are having the same state of vibrations. We call that as what? A wavefront. Right? Is that clear? So we can say that wavefront will always propagate in the direction of propagations of light. Right? So wavefront will always what? Perpendicular. Wavefront will always be perpendicular to the direction of propagation. So what is the direction of propagation? We said here. What we said? So light propagates as a wave, but the direction always will be represented in the form of a what? A ray. So how we are getting a ray means if I draw a tangent to a point, right? If I take a point, if I draw a tangent, and there will be a line which is perpendicular to that, which represents the direction of propagation. We call that as a ray. Right? So any point we can draw a tangent. So the tangent, if I draw a line perpendicular to that place, we can say that is the direction of propagation, and we call that direction of propagation as what? A ray. Is it clear to you? Right? So every point we can able to draw a tangent, and the tangent is perpendicular. If I draw a line is drawn perpendicular to the tangent, and that perpendicular line is going to represent the direction of propagation. So which is nothing but it is a ray, it is a direction in which the wavefront is moving. So we can also say the name, it is a propagation of a wavefront, or we can say that it is a propagation of a ray direction. Therefore we can say that the wavefront is always perpendicular to the direction of a ray. Right? So wavefront will always be what? A perpendicular to the direction of a ray. Then we say that the shape of the wavefront. Here I am saying this is spherical in shape or circular in shape. How this has been taking place? The shape. The shape of the wavefront is due to two things. One is due to the shape of the source. So here I have used a point source of the stone. I am not going to draw the biggest stone, right? I am going to draw a small stone, right? So which can be a circular shape. So this is a point source. So we can say that the shape of the wavefront depends upon the shape of the source, and also depends upon the distance of the source where it has been taken. Right? How far it has been very near to me or very far away to me. If you observe a lake or thing, if I drop a stone to it, we can observe a concentric circle, right? At the nearest point of disturbance. If I go on seeing that, means at the end, it will becomes to be what? A plane wavefront. So the shape of the wavefront is arises due to only two reasons. One is due to what? The shape of the source. The another one is due to what? The distance of the source at which the source has been kept. Right? Is it clear to you? So we get three types of shape. One is called as spherical wavefront, another is elliptical wavefront, and a plane wavefront. It is very simple. If I use a point source and the distance is very finite, we can see a spherical wavefront. Right? The similar thing. Instead of using a point source, if I use a linear source means what? A straight line. If I use a linear source means the equal distance everywhere. That will be equal distance and that will be occupied and that will give rise to what? So it will give rise to a cylindrical wavefront or elliptical wavefront. Right? So not elliptical wavefront, this is cylindrical wavefront. The next is called a plane wavefront. What is a plane wavefront? So plane wavefront is nothing but, right? So a plane wavefront is a one which gives rise to either by this point source or a linear source. So if the point source is at finite distance, it gives rise to a spherical wavefront, and the linear source of the finite distance, it gives rise to what? A cylindrical wavefront. Right? So both the source at infinite distance is going to give rise to what? It's going to give rise to a plane wavefront. If we take our sun as an example, right? Sun is at a very infinite distance from our Earth. So from that, it is when it is taken place means our Earth gets what? A plane source, right? So that is called as what? A plane wavefront. Is it clear to you? Right? So a point source with a finite distance give rise to a spherical wavefront, and a linear source with a finite distance will give rise to what? A cylindrical wavefront. And if that is both the sources with infinite distance, that is going to give rise to what? A plane wavefront. A plane means what? What is a plane? Like that, right? So if it is a far away or the distance it gives what? It appears to be a plane, so that gives me a plane wavefront. These are the major three shapes which has been taken place in what? Wavefront. And the wavefront depends, the shape of the wavefront depends upon the what is the thing, shape of the source and the distance at which the source has been kept. Right? So with the help of this knowledge, what we have learned about what is meant by wavefront, how the direction of propagation of wavefront is there, and we have learned about what is meant by wavelengths that has been applied by a principle. We call that principle as what? Huygens principles. So now we are going to learn about the Huygens principles. With the help of Huygens principles, we are going to prove the law of reflection and refractions using the Huygens principles. Right? So we will see that.